This is another episode of Trigonometry. This is part 3. So, now, we just discussed the unit circle and what the circle has to do with radians. So, I think my pen's completely gone for now. So, now, we have our coordinates right here. There's the origin, 0, 0. And a circle of radius 1. Okay? Now we correspond angles with arc along the circle, right? Right here, this 45 degrees, right? Half of the 90 degrees between these corresponds with a pi on 4 distance along the circle, like that. So instead of saying this angle is 45 degrees, we just say it's pi on 4 radians, but you don't need to put the radians down, okay? So, using this, we can now talk about that a little more. So I have my right angle triangle here, right? This is an angle theta. The coordinate, as we discussed last time, is going to be cosine theta, because this is hypotenuse 1. And sine of theta, that's your coordinate, okay? So, if we write theta in degrees, it's basically just going to be this distance along cosine and sine, okay? So that's the idea, right? You're going along a circle. You're going along this circle, taking the cosine and the sine, and plotting that point, corresponding with your angle theta. So now, let's go ahead and talk about the graphs of cosine of theta and sine of theta. Okay? Let's talk about their graphs. But first, let's convert some degrees to radians. We said that 45 degrees is pi on 4. We said that 60 degrees is pi on 3, and that 30 degrees is half of that, which is going to be pi on 6, right? So now, and we also know that 180 degrees, this is the portion one, is pi, meaning the ratio is pi radians to 180 degrees, okay? Meaning, if I multiply this by 45, you actually get pi on 4. If I do pi on 180 degrees times 60 degrees, you get pi on 3. And you can keep going, and you convert all of them by multiplying on pi on 180 degrees. Okay? Meaning that 80 degrees in radians is like multiplying by pi on 180. You can reduce this to 4, that to a 9. This is going to be 4 pi on 9, right? So, 75 degrees to radians is then going to be, well, 75, you can get rid of the 5 there. 180, you can get rid of the 5 there. It's going to be 36, right? Right here. 75 on 5 is going to be, well, 15. 15 and 36 don't really share anything, so 15 pi on 36. This looks a lot uglier, these angles, but it actually is a lot more useful. We'll see that later on, but right now, let's just move on to the graphs. I was not supposed to erase that circle. I'll just make it smaller. So, if theta is 1, this is our angle theta, is 0, not 1, sorry. Let's go ahead and graph cosine, okay? This is cosine theta. What's right here when theta is 0? This is our theta axis, our angle axis, and this is our y-axis or our cosine axis, right? So, or x, because it's the x coordinate on the circle, okay? This is a radius 1, so this distance right here is 1. This is a point 1, 0. So cosine of the angle, which is 0, cosine of 0 is going to be 1. Okay? Now, let's move along to pi and 4. Right? Pi and 4, it's going to be 45 degrees. It turns out that the cosine of that is the square root of 2 on 2. You can check this on your calculator. Where's the square root of 2 on 2 going to be? Well, square root of 2 on 2 is going to be right around 1.4, right? Dividing that by 2 is going to be right around 0.7. So 0.7 might be right around there. Yeah. Right? Square root 2 on 2. Mark that point down. Let's go to pi on 2. The x-coordinate there is 0, obviously, because look at that. It goes down onto 0. So doubling this distance doubled. It's like pi on 2, it's going to be 0. If I keep going, I'm going to go back down to square root of 2 here, or negative square root of 2, because now we're on the other side, then to negative 1, and then back up. It kind of follows this wavy pattern. I drew that really badly. So if I zoom out a little bit, right? If I don't have it so big, right here it's going to be 0, it's going to be 1, pi and 4 is going to be right around there, then it goes down, then it comes like that, then it goes back. It follows a sort of wavy pattern, right? It follows like a wave. If I zoom out even more, like insane amount of zooming out, it'll look something like that, right? Like a big wave. And you can imagine this going in the other direction, right? Because instead of going like that along the circle, you're going like that along the circle. Negative angles. Okay, this is cosine theta. You can imagine that it's going to be right around the same with sine of theta, except a little bit shifted, right? That's going to be sine of theta, cosine theta, but shifted along the x-axis. So let's separately draw sine of theta and think about it. So at 0, it's actually going to be 0, right? Because our y is 0. At pi and 4, it's also going to be the square root of 2. So right around there. Then at pi on 2, let's label it pi on 2, it's going to be right around pi on 2. It's going to be 1, right? Because it's a distance 1 from the origin. Then it goes back down. So now it's going to be the same sort of pattern, but shifted, right? From cosine, because cosine looks like that. I drew it very badly. it's supposed to go at 0 at pi on 2, right? Then it peaks there, then it goes back up, and then it goes down like that, okay? It's like a shifted version of cosine of theta. So now, these are some problem questions. 1. What is 80 degrees, or we already did that. What is 50 degrees in radians? 2. What is the cosine? What are the side? What is the angle of this right triangle? Right? So I'm talking about theta in this case. Theta. And it's going to be a 5 and a 4. Also figure out this side length. Right? What is the side length? The hypotenuse. Hypotenuse of this right angle triangle here. And number 3. So in this one, you're finding theta and c, the hypotenuse. And number 3, what is the angle and side? Hypotenuse of this. Right? So theta, this is a 13, this is a 12. Okay? You have to find both theta and make sure theta in radians. Okay? Make sure it's in radians. Convert it to radians. Okay? And that should be our job here. But I just want to make another point here, just in the final sort of bit of the video. The equation of a circle, well, the circle is the set of all points whose distance, right? So if I have a point xy, it must be a distance 1 from the center. Okay? Must be a distance of 1, right? This is the distance equation, x minus 1, 0 squared. This is from 0, 0. X minus 0 squared plus y minus 0 squared. Square root it, because the distance formula has to be equal to 1. Square both sides, x squared plus y squared has to be equal to 1. We know that on the circle, x and y are like cosine and sine. So x is your cosine of theta, and we're squaring it, so I put the exponent like that. And then the other one is going to be the sine of theta, which is then going to be there. I put the exponent right there. It has to be equal to 1. And this is an equation. We'll go into more equations later. Let me redraw the triangle from before, just in case you hadn't copied it down in time. 12, 13C. Okay? So this is our triangle, and those are your problem questions.